Alright, today we're going to be doing a CTF challenge, a web CTF challenge called msfrognymize. And this challenge seems to be a web challenge made by the Crusaders of Rust. So first look at it is just a simple web challenge. I'll just choose a random file to upload. Open and upload. And as soon as that file uploads, it's processing the image. And then we just wait for a bit. And we see that a random frog is just generated in the picture. So we have an idea what this web app does. Just generates random frogs, I guess, anywhere. It detects a face. That's what I'm guessing. And now we just look at the source code. This challenge is just a LFI challenge for the most part. Because if we look at the Docker container, Docker file, we see that the flag is located in the root. So the flag is going to be in .-flag.txt. Because if we go to dash, this is where everything's at in your Linux system. So I'll just like nano flag.txt. Hello world. I guess I don't have sudo. Maybe I don't know. Well, alright then. Home. Now if we cat flag.txt, that's exactly where we were at. So flag is located in, I guess, in this directory, because pwd flag is located all the way past this in cd pwd. Flag is located in this directory, and that's where the flag is at in this web app. So we have an idea where the flag is at. Then looking at the, I just wrote this flag. Yes. Oh wait. I mean, cd home. Core cd ms cat app. Looking at the source code of this, we see all the, I guess, everything. But the main method that seems to be vulnerable in this web app is probably the os path.join. This seems to be the main vulnerable. I guess the main thing that's super vulnerable, because if we look at the documentation, or like looking at the documentation, you find out that if the second parameter, which is this parameter, is an absolute path, that means the first parameter gets rejected. So an uploads folder, in this case, if you go up, I think uploads folder is upload slash. And if the second parameter is an absolute path, then it ignores the first parameter. So in our case, if we do, let's go on python.3, and then if we do import os, and then after that you do os.path.join uploads, and then you put like just a file name. It'll be like a file.jpg. If we do this, we see that it concatenates uploads and file.jpg. It concatenates into one. But there seems to be a rule or a bug in this where if you do, if you add an absolute path is just a / in front of this, it ignores the first parameter. So it's going to be file.jpg. So this is when we start thinking of accessing the file, or LFI in that case. So we could just change this to flag dot txt, and then we see that we're able to see the flag file. So I'm guessing the whole point of this exploit is to cat app, go all the way down, and anonymize the image file. We just anonymize, we accept of putting the uploads folder. We just had to replace it with a flag.txt, but with the dash. So let's try doing that. And also, we can't seem to forget about unquote with unquote. If you look at like a unquote Python, all it does is it replaces escapes with their single character equivalent. This is encoding, so it just, for here's an example, unquote, this is URL unquoted, it returns it as El Nino. But I guess the problem with this, it only does it one time, so we could just do a double URL encode. So if we go back to here, and we just change this to encode URL encoding. So we just do this and then encode it to F. Now if we double encode it to F52, so it's gonna be our double URL encoding. Now it's double URL encoded, and then after that, all we need to do is simply just add flag.txt at the end, and we get this. But if you go and inspect, control source, we see the flag from privacy to LFI. That's about it for this video. I'll link the write-up down below that goes even more in depth, but this is how I understood it. So I guess the main source of this vulnerability was the OS path .join, which is pretty cool. I didn't know about this, but now I know. Pretty cool vulnerability. Anyway, that's about it. Peace.